Hi there, I'm John from CNCKing.com, and today we're going to make version 2 of this paddle boat. So this is the first version of it, and this is the second one that just came off the bed. Now sadly, I already took most, it kind of came off just from me taking it off the bed, but the most satisfying sound you hear from 3D printing is this. And the reason why it's satisfying is because if you hear that, that means your print didn't come off the bed, which means that you didn't make scrap. So let me just put it together real quickly. So this is the base. You see here. These are all support materials, so they're meant to come off. It's not a design flaw. You can see here. So what this does is just gives more surface area. So when this is 3D printing, there's a little bit more surface area so it doesn't want to come off. Because again, the worst thing to happen with 3D printing is when the model actually comes off or gets knocked down or just delaminates. Now there's a lot of different changes that I made to this paddle boat. The first version I downloaded from Thingiverse because somebody already made it. I'm assuming somebody already tested it out and it worked great for their application. And then I did it and I found out it's actually not that good of a design, to be honest with you. So this is version 1. So the first thing you notice, this is when you wish you had more hands. First thing you'll notice is this thing here is supposed to spin, so that's pretty straightforward. So you go this way actually. This is the front. And it spins like this and it creates power to move this forward. So the first thing is, you'll notice this is sort of cut a little bit. And the reason for that is because the designer made this far too thin. And for the machine that I have, which is an Endo 3 Pro, you gotta remember, the bed is moving like this all the time. And if you have a small little section that just doesn't adhere properly, or that's a little bit off, and then the next section, the next layer, is a little bit off again, what you end up happening is zero adhesion, and it just comes right off, just like the support material. So let me just take the elastics off here. So version 1 is this one here with the elastics. Version 2 is mine. You notice it's dramatically beefier, but you'll also notice that here it's flat. So if you're pushing water and it's a flat surface, the water's just shooting everywhere else. You still get forward momentum, but you're losing a lot of momentum because of that. Version 2 is what I designed. You notice a little bit more of a paddle here. So there's a bit of an indent or thicker edges. So that means when it's pushing forward, there's a lot more power to it. So therefore it should have more forward momentum. This is for my kids' bathtub play, so I'm probably overthinking this quite a bit, but this is what I like. Overall, the thickness is about double, and this is dramatically strong. Just holding it, you feel, this thing's not falling apart. This thing here is just really, really flimsy. So that's one change, a big change. The next change was this. I just completely redesigned it. I didn't like any aspect of this, the 3D model of it. I like using chamfers, and I like having straight edges everywhere. So that's what I designed. So it looks similar, but it's completely redone. And what surprised me with this is I wasn't sure if it was going to be watertight, and it actually was. So that means when this goes in the water, it doesn't fill up with water, which is actually pretty cool. Version 2 of it, made it slightly thicker. The fins again with version 1, these were too thin and they broke off. Version 2, I have a lot more fins. So therefore it doesn't want to go like this as much. It wants to go in a straight line, at least that's my thoughts. The other thing that I never understood is why these pegs are so long if the elastic is down here. And there's nothing to keep the elastics there. So in my version, I made 2 versions of it. I made the pegs a lot shorter because it's redundant to have them that long. It wastes material. Then the pegs just go in here, and what they would do is they'll hold the elastic in place because of this. So let's take a look at this 3D printing. If you're serious about 3D printing, you must learn how to 3D model. Now the learning curve is incredibly sharp on that. I'm lucky I learned it in my 20s and it was just fun. I've been doing it probably since I was 15 or 16 with Strata Studio Pro and other sort of programs that no longer exist. But all of those programs, you had to pay for them. And nowadays you can actually get Blender, which is free. The user interface is absolutely dreadful for that compared to 3D Studio Max and other 3D programs, but it's free. So learn how to 3D model, and then when you know how to 3D model, you could download other people's prints, or you could pay for them, you know, whatever you want to do. And then after that, take a look at the model and see, you know, put yourself in their eyes of the designer and say, well, why do they do this? Why do they do that? You know, maybe this shouldn't be happening. You know, there's some thought behind every model, no matter how awful it is. And what you should do is, once you see the model, is take some lessons from it and then make your own. And that's a lot more fun. That's the fun process of 3D printing. When you're 3D printing, you're honestly just pressing a button and it's printing out. That's boring. You know, this is the last step of the design process, not the first step. So if you learn 3D modeling, it opens up a whole new world for you, especially if you want to end up running a business doing this kind of stuff. You know, who's going to be your competition? You design your own model, you own the copyright to it. It gives you a lot more options in life and options, you know, in 3D printing in general. Just scaling models up and down that you just download from Thingiverse and sites like that, I don't see the point of that. It's not the good use, for my personal opinion, for 3D modeling. Now you'll notice on the first version of this is the second version, and you can tell right off the bat because the orientation of the boat was 90 degrees to what you see here. And I think that's one reason, not the main reason, but one of them, as to why I had problems with adhesion as the layers went up. It's because the fins on the boat were facing the wrong direction. You have the platform moving forward and back, and you have the fins going left to right. So therefore there's a little bit of stress or maybe a little bit of leeway there. And maybe that caused for not proper adhesion for the top part of the fins and therefore the paddle. This case here, when I redesigned it and 3D modeled it, I made sure the orientation was the other way when I did the 3D print, so that then all the stresses are basically gone. If you have a solid fin, no matter how thin it is, generally speaking, there's not much stress on it if it's going in the same direction as the platform. Now you also notice that when I 3D model this, I have almost no space between the paddle boat and the paddle thing. And that's really nice with 3D printing because you can have 3D areas of making parts fit together, which is something you don't have with any other CNC machine out there. So I hope this project gives you an idea of why learning how to 3D model is vitally important if you have a 3D printer, especially. Because with 3D printing, you have XYZ, and you can model and design anything along all of those axes. But also it allows you to make more complex shapes and sort of toys, if you want to put it that way, using other CNC machines, but use a 3D visualization that helps you make stuff. So I taught myself 3D Studio Max, 20 years ago? And I've been using it on and off, ever since. And it's been a wonderful way for me to download a file, see how it works, see what doesn't work about it, and then actually be able to rebuild it completely the way it should have been done to begin with. So if you don't have money for 3D Studio Max, which is an expensive program, there was also Blender. I didn't learn Blender because they didn't have it back then. There's only 3D Studio Max, there was Maya, but Autodesk bought Maya. And there were a bunch of other programs that just sort of faded, like Strata Studio Pro, Bryce. I loved Bryce for modeling, geography and stuff like that. So that's something I want to do with the 3D printer as well. So there's lots of options out there now that didn't exist, when I was in my 20s learning all of this stuff myself with my laptop. So you can see here, it's easy to spin, but you can already just feel how flimsy it is. And we have my version. Yeah, I love this one. It's so much beefier. It definitely feels like something of quality compared to this one. This one feels maybe about 50% heavier, which is what I like. That's something that a lot of people forget when they design things. Let's say, especially for corporate awards and that kind of stuff. If it has no weight to it, it just sort of seems to be missing something. So that's why you sort of hide in metal and other sort of things to give it a lot more beef. But for 3D printing, it's the same thing. You know, I have medieval castle walls here, and it's so lightweight. You know, if I had a better printer, I'd probably do 100% fill for these kind of things. And that's to give them just so much more weight. It doesn't feel good to have something and it feels like nothing. It's just strange. So if you're looking for custom 3D modeling or CNC work, contact me at CNCKing.com. We'll make it for you, and of course we can design it as well and ship it right to your door.